look at how much control you have in these prompts. Here's a longer one.
So you're saying a language model can pretty much do your job?
False. The combination of silicon and human flesh is superior.
I mean, that's crazy. Even the typing, the chatter behind, like, the audio is pretty legit on this model.
Yeah, 32 kilohertz. We're almost approaching MP3 quality, right?
All right. Welcome, everybody, to Fine Tuning Friday with Oxen.ai. Today, we're going to be digging into one of the most exciting open source, open weight releases in recent history. We're talking about MiniMax H3, this model from the team at MiniMax. It is an open weights general purpose video model that is kind of on par with Seedance, which is pretty crazy. You can run this thing locally. I've got it up and running on my GPU under my desk right here. You can run it in ComfyUI. I've seen people run it on their Mac hardware, and the quality is pretty dang good. So today we're going to be digging into this model, showing you some live generations, and showing you how to fine tune it. We're going to try to pack a lot into this 45 minutes here, so stick around. You're going to be learning a lot. I've got my trusty partner in crime, Phil, here, who runs a lot of the ComfyUI live streams. He's a diffusion expert. Phil, you want to introduce yourself?
Yeah, sure. Thanks so much for having me, Greg. This is awesome. Been a fan of everything you guys have been doing at Oxen for a while now. Yeah, so my name is Phil, also known as Machine Delusions. If you've used the Phil Nodes pack or any of my purple nodes in Comfy, you're probably well aware. I have easily 15,000 hours of fine-tuning, experience throughout the years. And I've professionally worked in multiple countries and multiple industries for just diffusion and AI generative tech, including Japan for the anime industry, and then a couple of studios for more like feature production films, and more recently advertisement and just like general like full stack development. Um, but yeah, I mean, I could talk all day on that, but yeah, I'm super excited to have the ability to finally see like open source video models catch up to like state of the art, which is that's a big moment because video models are hella expensive to make. And so the fact that we're just given it for free to build and play on top of is seriously a blessing.
And check this out. So this is from the Design Arena benchmark on image to video, and image editing. MiniMax H3 is state of the art. So it's not even a good model, it's the best model on these three categories, which is just crazy to think about. That being said, Seedance 2.5 was released last night at like 11:30, so
Of course
who
it
knows
was.
if it'll hold the crown. But
There's
Phil, I
like
know you, yeah,
I was gonna
yeah.
say there's a caveat here, right, with this list. For anyone who doesn't know, like the Minimax pipeline is actually like a three-stage pipe. The first stage being taking all the references, your prompt, your image, your video, audio, etc., embed it right into tokens. Second one is like they call the 768 pipe. This is all on the model card on Hugging Face. But there's one piece of the pipe that they did not open source, which is the 2K resolution, what I'm assuming to be probably like a refiner pass, similar to like LTX, where it's like a upscale GAN or a small adapter that just slaps onto the back of the DIT or something. They did not release that. So those benchmarks we're seeing are the closed source variant of Minimax. Um, you and I both know we've been fighting to like get it super crispy, but if you use the API, it's good. It's very good.
Yeah, and we're going to be digging into how you can use the API. All of these models are available on Oxen.ai if you want to try them out. We've got MiniMax H3 right here. We added Seedance 2.5 late last night. I think I added it at like 1:30 a.m. last night. So if I'm a little tired, that's why. Um, but I was playing with this thing and I've been seeing some fun examples on the internet of just like what it can do out of the box without even reference images. And like it was clearly trained on every American TV show,
Everything.
movie. Like it can just spit out The Office word by word here. I think I have to unshare and reshare my audio. But Phil, you can fill some space before I play
Yeah.
these videos.
No, Greg, Greg is not exaggerating. He can literally do everything. I've seen videos online of people like doing mix-ups. I think that's the most impressive part is like people rendering SpongeBob like 2D American style stuff and then also mixing it with like Brad Pitt and live action in the same like frame and it just like can totally discern the styles and there's no bleed or anything. The audio, it all looks the same. Variable frame rate and realism in the same shot. Like that's crazy. For people who don't know what a variable frame rate is, it's when the frame rate that of the playback of the animation is varied in the sense of like sometimes it's playing on every frame, sometimes it's every other frame, sometimes it's on the thirds, which makes it feel like this like laggy thing. And so animation, it's like a variance, it's like this like moving thing back and forth through time of frame rate, but like it could do all that in one render and I don't know, it's just insanity that they
It's
gave this
crazy.
to us, you know what I mean? Like
Yeah. And so check this out. This prompt, granted, it's going through some of their pipelines under the hood, literally just said Jim and Dwight from The Office discuss autonomous coding agents. So let's see what came out.
Coding agent beat you? So the autonomous coding agent beat you?
False. I am the ultimate biological algorithm.
It came up with that dialogue itself, right? Which like I didn't say anything about Dwight saying false or, those like camera angles or pans. And it just like it did all this.
So the
so
autonomous
there's
coding agent beat
you
you?
didn't put any like
False.
prompt modifier in between that?
No, so this was just raw, straight to the API.
Okay. API, got
Straight,
it.
yeah. So we'll be talking about running it through the API versus running it locally. Um, if you've been following this model, you'll see chatter online. And let me pull up this example, AI Warper. I strongly encourage you to adhere the prompting guide released by Minimax. It helps with getting exactly what you expect. And so, like, clearly here, I didn't enhance the prompt at all. If you go to the Hugging Face and you go into files and versions here, and then docs, they have pretty detailed prompt writing guides here that would be great for you or your agent to read as you're coming up with
Let's be
prompts,
honest, your agent.
your agent. And even things like they have custom tokens that they train this model on for dialogue. So this model can do like what, 9 different languages, I think,
Yeah,
out
I
of the
think it was
gate.
11.
11.
It was a
So
lot. Yeah.
more than I can do for sure. And how that works, how they trained it is they have this like opening D tag and closing D tag, and then you specify the language. So if we go back to our example here, they took this prompt when we hit the API, ran it through some sort of language model, some sort of system, and came up with a prompt that looked more like this. And so this is my version of using a more detailed prompt where I define shot one, I define shot two, I'm defining the timestamps, and I'm being very specific about the dialogue that I want. So let's look at this one. This is having Jim say, so you're saying a language model can pretty much do your job. And then it goes to Dwight and he says, false, the combination of silicon and human flesh is superior. Now, I messed up here and did a 5-second render instead of a 12-second render. So we're going to look at both of them and just see. This is the same prompt, just different durations.
So you're saying a language model can pretty much do your job?
False. The combination of silicon.
Okay, so we were trying to like jam too much into that, but like look at how much control you have in these prompts. Here's a longer one.
So you're saying a language model can pretty much do your job?
False. The combination of silicon and human flesh is superior.
I mean, that's crazy. Even the typing, the chatter behind, like the audio is pretty legit on this model.
Yeah, 32 kilohertz. We're almost approaching MP3 quality, right? 44 kilohertz, which is insane because most music generator models that exist today don't even hit that, right? Like you got Suno and Udio, and then when it hits open source, you've got A-Step, which is I think 24. So this video model out of the box has higher fidelity than an audio model that was designed for just audio, which is just
Wow.
insane. Yeah.
Yeah. And before we started the stream here, you were telling me a bit about some of the audio generation stuff you've been digging into. So excited to see some demos or hear some examples of that in a bit. Um, Before we get into that, I do want to call out, I mean, this is an Omni model, so it has all sorts of controls. It has your first frame and last frame if you want to interpolate between frames. It has up to 9 reference images that you can pass in, so very Seedance like in that aspect. If you want to see an example of some reference images being passed into this, I was messing around with a little kind of animation here of our character Bloxy. And so I passed in like a few character sheets of him using samurai swords, him from a couple different angles, and then a long prompt of him fighting uh, some people in the forest, some ninjas in the forest. And so it's just taking all of these reference frames for what our dude should look like. And it's not following them literally, but it's using them as reference and guiding. So again,
Pretty good.
animation style, realism, like a pretty big variety of what this model can do. It can also take in reference videos like Seedance, so it can do kind of video editing, style or like camera movement transfer or pose transfer. Have you played a lot with this, Phil? I haven't gone down this rabbit hole too much.
Camera and pose transfer.
Yeah.
I've kind of done something straight down the middle, which is take this character and swap out the person in the shot for the character. So taking like I think it was a video of like two people dancing, like a TikTok dance, and then I took two very obscure illustrations of just characters and hot swapped them, and it totally did it. So
Wow.
yeah, it's pretty crazy.
Super cool. And then the last modality is just reference audio. So if you're driving a character trying to do lip sync, you can pass in reference audio, or you just want some background music or something like that. So through the API, it can do the 2K, it can do up to 15 seconds, and a bunch of different aspect ratios. The really exciting part about this model is what you can do locally with it.
Yeah.
So there's a few interesting things I want to call out. One, I got this thing running on my GPU kind of under my desk here, and I just kind of wanted to show you what it takes VRAM wise to run this thing. So I have 2 GPUs on this machine, each with like 48 gigs of VRAM. It is a pretty beefy model, so I could barely fit it onto one GPU if I wanted to. It was around like the 43, 45 mark without running anything. But then once you start generating videos, I got some ooms. So I decided to split it across 2 nodes. And what's interesting is if you look at, and I think the ComfyUI packaged version of this is the best way to look at this, is you have both the text encoder and the diffusion model and the they. And so the text encoder itself, it's Qwen VL32B, which is a pretty powerful text encoder in itself. But you can see this int8 Convrat version is about 27 gigabytes. So that's what's loaded on one GPU. I also loaded the bays on that same GPU, and then I did the diffusion model on the other one. So this pruned int8 Convrat on the other GPU. So Comfy did a great job of packaging these up in a bunch of different floating point 16, floating point 8, int8, and this is what, Phil, you've been running in Comfy as well.
Yep. I've been running totally local. Yeah, just like really trying to like get the best quality out of it. If you can you go back to the official Hugging Face for a second?
Yes.
Yeah, and then on the model card, and you scroll down, that illustration you were showing, keep going down. That one
This
right
guy.
there.
Yep.
Yeah, this is what I was talking about, right? Like they've released up to the 768 marker, that yellow chunk in the middle there. So, most of my efforts have been like, how do I get the quality? How do I get the quality? How do I clean up the noise? How do I, the motion of this model at low res is insane. Like it's so good. The quality is absolutely terrible, but it doesn't matter because it's like the motion is arguably the harder part, right? I can always just pass it through another K sampler, run it again, run it again, clean it up. But I've been very impressed with like running it 512 long side and being able to get cohesive motion out of the thing enough for me to be like, yeah, that's what I wanted, or like, no, that's not the direction I thought it was going to go, right? So I can just like iterate really quickly in super low res and be like, oh yeah, that's okay, that's the one. Okay, now upscale it. And now I'm not wasting literally half an hour, trying to get a video I don't even want high res.
Cool. Yeah. I want to see some of those pipelines you got
Yeah, totally.
running. A couple fun posts that I found. This is from Simon Willison, and he got it running on his MacBook M5 chip MLX. And he just like YOLO'd this and downloaded all 115 gigabytes and did a video gen. It took like 45 minutes on his MacBook, but like crazy that you can get this out just running locally on a Mac these days. Like, what the heck?
Yeah,
Uh,
that's impressive.
and then shout out to this one too. We work a bit with Shadowworks here, who got this running on his 6-year-old GPU. So this animation pipeline here, check this out. And this is like the power of open source, because people are just hacking with this, running it locally. What is this? An RTX A 4500 20 GB VRAM? Like, I'm not going to play the whole thing, but you get the idea. Like, you can run this thing on a potato.
Yeah, this shout out to Shadow because he did a lot of amazing work. The whole point of that post was he was exploring what the model foundationally already understood. And it turns out it understands basically everything, right? All the classic tropes and techniques that traditional animation would go through, right? The whole like bulge and squish mechanic of like, items moving and like morphing. That's really what he was testing here. He was testing to see if the model understood all of those concepts and like different modes of animation. But yeah, amazing work because I watched them all and I was like, oh, it could do that. It could do that. You know what I mean? I was very much informed by watching that thing.
Yeah. really fun 6 minute watch. Um, and then as I was hacking on this, I decided to build just like a for vibe code a little UI for myself. If you guys want to check it out, let me find this thing. GitHub. Where did I put it? MiniMax H3 UI. So I did a bunch of renders last night, a bunch of different styles, just like testing it out on Breaking Bad, on Will Ferrell eating spaghetti, on Steve Jobs announcing Oxen.ai, and it's just like crazy the variety that this thing can do. And I think this will be a good segue into running this locally versus running through the API.
He's
Um,
don't been saying, Nanny.
okay, so this is our same prompt of Jim and Dwight from The Office discuss autonomous coding agents. And so this is raw, straight out of the model. We haven't done any prompt enhancement. This thing knows how to speak a bunch of different languages. Listen to the audio that comes out here.
He's don't been saying, Nanny.
Dit nu al het inleidingskaster bij de automatiserings.
With issues playing into the bracken I've been in Celia's Toro Annex Thoughtingans. My.
He's don't been.
Okay, so it's like speaking gibberish, or maybe that's a real language. I'm not sure. You really have to run it through a pipeline like this to get the prompt exactly how you want it. And so even with this little tool here,
He's don't
what I
been saying,
did
Nanny.
was I set up my prompt bar here, and then I set up a little magic wand that went and took that Hugging Face doc, used it as context, and then it'll rewrite my prompt given that template there. So you can see it wrote some dialogue for me. It put all the brackets in. It broke down like the multimodal description versus the soundscape versus if you wanted music in the background. And so this is what it's kind of doing under the hood when you call the API. And this is the output of that kind of LLM enhanced version.
So you're saying a language model can pretty much do your.
Yeah, there's a couple of questions in the chat, Greg.
Yeah, let's go through them.
First, how long does it take to generate a 5-second clip with your rig?
That's a good question. So this was a 20 or a 10-second video, and it took what divided by 60. So this took like 27 minutes. Phil will show some ways to speed up kind of the preview time
Totally.
and run it in ComfyUI, but this is just like running the raw model weights through my GPU here.
Also, Kelly asks, how do we deal with copyright infringement when using copyrighted IP? That's a spicy question. Is this accepted within the industry?
Yeah,
I would
Phil,
just say avoid. I would just say avoid it. I mean, like, the model can do it, right? Like, that's really the only way. If you avoid the copyright, you're probably going to be fine. If you're deliberately trying to get Tom Cruise fighting Brad Pitt, like, you're going to have a bad time, you know?
Yeah, like this.
I knew you had it somewhere.
It was in here.
Yeah.
But yeah, and like, similar to other things, you're judged on the output of your work. Like, don't plagiarize all the kind of things you learned in school. But what's really cool about this model is like, if you are a studio that does have the rights to the actor, you no longer have to fight with the censorship from Seedance or like any of these APIs that kind of block you from doing these things. So I think this is going to be really valuable to high-end studios that are working with real actors or real IP. Like, they can now use that IP or train their IP directly into the model, which I think is super exciting.
Yeah. Yeah, the other thing too here is the model is like actually fully uncensored. So it can do violence, it can do gore, it can do porn. I was testing all that actually last night, and I mean, it'll do it, it'll 100% do it if you ask.
and the quality is just insane. Like this is Seedance quality locally to me. I mean,
Yeah,
that's
I
nuts.
agree. Yeah. I think the fidelity of the actual render needs to get a little higher for, in my opinion. Just because I'm, super judgmental of like mushy pixels.
Yep. And if
But I
you're
mean,
doing
like,
any
look at that motion, dude. What? Play that one
yeah,
again. This is crazy.
and if you break this one down frame by frame, I've actually tried the gymnastic thing on all the models, and I'll show you Seedance too. But like, okay, you'll see where it breaks down. It's pretty good, pretty good, pretty good. And then right about here, her like head
Yeah,
turns into her feet,
the shifts.
and then
Yeah.
she's like half and half, and it gets weird. But that happens on Seedance too. Like if you ran this through Seedance, it flips where her head is all the time. So these gymnastics ones are always fun ones to see if we've actually solved some of the motion. Um, but even like high speed car chases here, like pretty smooth, pretty cool.
hmm
Phil, let me hand the reins over to you and let's show some of the audio workflows. Let's show some of the stuff you've been doing in Comfy because I
Sure.
think
Yeah.
you've really been exploring the inputs and outputs of this thing.
Yeah, totally. Let's see. Yeah. You guys see that?
Yes.
Sweet. Okay. So, I mean, I've been spending a lot of time actually building like custom pipelines, custom not even pipelines, like custom nodes, conditioning, really like being like, okay, well, I have this crazy model. And it's like, yeah, I can prompt harder to like get my results, but like, I'm a coder, I'm a hacker. Like, let's do something that no one in the world has done, right? And so, I'll get into that down here, but this is a really interesting one. I was trying to play with the idea of like, okay, this is an omni model. What can I do with that? What does that mean? So I set up this pipeline that I give it a single picture, and then what the prompts are, it's like take this image, create a time lapse of a carving coin, a time lapse of someone getting tattooed, drawing with a pen, someone making a digital collage with MS Paint, and it does it. It just like takes the image and makes these time lapses. So like in my mind, what I was playing with here was I was treating the model like Nano Banana, right? I was just making edits or making like, you know, here's some ingredients or whatever, go do the thing. This one blatantly failed. But I have some other examples. I think this one with the frog. Yeah. Yeah, this one, same idea. But it was done with the frog. And I mean you could
I
see the
think we're
frog
still
image.
on the other
Oh,
tab.
right, right. I'm not sharing my let's see. There we go. You guys see that?
Yeah, I think so. Yeah, there's the
Yeah.
frog.
Yeah. So this frog is, an example of just again the same pipeline. The whole pipeline does all four videos at the same time and then just puts them together. But I thought that was like really, really interesting and just like playing around with just like those kind of like capabilities. The other thing I've been playing with is some audio reactive stuff, and this has been super fun.
You might have to reshare with the
Share with audio.
audio on. Yeah.
Classic share sound. Let's see. How about now? I have to stop it, maybe.
Yeah, I think stop and restart.
Classic. Share sound. Full screen. Yeah. So this is pure prompting. which I thought was just insanity. I've got some more examples of the audio sync stuff.
So that was
Um,
an input audio and a prompt.
Correct. So yeah, so
Yep.
down here, actually not in this workflow. Yeah, that's a bad examples. Let me go to my outputs and grab one that actually did the thing. But yeah, the that was me bypassing all generative audio and going straight to, here's the song, do the thing. And that looks something like this, right? I'm taking in the song, I'm cropping the audio, I'm turning that audio into that 24 FPS to a frame count, and then I'm feeding that into the reference, right? And here we have my reference image, the reference audio, these two lines here, and then it goes into a K sampler and renders the thing. And then, my prompts were sometimes following the guide, sometimes not. I was kind of all over the place at this moment in time, playing to see what the model would do um, without that without the prompt guide. I mean, the prompt guide is amazing. Like 100%, we should always be using it because it's just so good. It was trained that way. But then I started to go down like custom designing audio reactive pipelines via like custom nodes. And these were super fun. So check this out. So this is just a kick and a snare loop, but it's just so satisfying to like have it all be like completely beat synced up. And then then I started to get really fancy with it. And I was like, okay. And then I was like, okay, like I need to design a better control uh medium for me to do this kind of stuff. So again, if anyone's used my custom nodes, the class, every purple node here is custom and I built in the last couple days. But this node is really doing the bulk of the lifting. It's called FL Beat Prompt Schedule. It's not, I haven't open sourced it yet, but you click this button and you get a whole control board, right? And so on the left side here, I'm just selecting my song. And then the song is put up here at the top. I can use these sliders to kind of like find my moment in the song. And then under it is the literal the beat that's associated with that moment. And then these are my prompts. So I can play this back. And so you can see that it's like on the beat. 1, 2, 3, 4. Switch the prompts. Switch the prompts, right? And so like it allows me to really get granular. And then I also added in this ability so that the way that this tool works right now is each one of these chunks is technically a different render. It's a different latent, right? And so what I can do is I can take this whole 3-minute song, I can schedule it out, prompt it all out, with the blocks of time, some bigger, some smaller. It doesn't have to be equal. All right, I can click and drag these around to be any size I want. So it could be 1 beat, it could be 2, it could be 2.5, it could be whatever. But they are all individual renders, and then they all get stitched back together. Now, that's great, but the model can actually handle multiple. It can handle multiple cuts, right? You just prompt for a cut, a scene change, right? And so the way that I handled that was I can just shift click multiple and then right click and group the selected. And you see this like blue line at the top here. That line, and if I do it again over here, it's a different color, maybe these three as well. These lines at the top here, they represent that I'm taking those 3 prompts and now it's one latent, it's one render, right? And so I'm scheduling prompt changes in the same video. But if I don't have that line, if I just leave it like this, they are technically 4 separate videos. And I can have a combination of the 4. And so what that allows me to do is some pretty ridiculous stuff. I could do, let me just try to find a good example. Yeah, I think this one is probably the best one I've got so far. So I'm like prompting for all this chaos, but it's like the videos are cutting on the beat, so it's every like four. Or no, it's every two. And then I'm just doing like every two, and then it goes into the chorus, and now it's like every four. Switch. Switch. Right? And so I can like dictate a whole music video. That was one render. I literally hit go once. It was 36 seconds of time at 24 FPS. I didn't like I did all the work here and I set it all up. This is literally that render. I set it all up and then I just hit go and it like I'll do it right now so you can kind of see. And then, again, I don't want a prompt, right? So let's do this quickly. What's this beat? Okay. Yeah, that's fine. Let's just leave it like that. And then I'm gonna have this character reference, and then I have my agent over here on the side. Um, Again, another custom node that I've built, but it's basically a full MCP for Comfy. I could be like, wait, do I have? No, it's not on. There we go. Take a look at the character we've loaded right now. What I want to do is make a music video based on the timing that we already have, where he is walking through the park, getting ice cream, and then he drops it on the ground, and a bunch of pigeons come and eat it. Let's write those prompts out in the current timing that we have.
Love the
Okay,
voice input.
oh, it's the
That's
best.
awesome.
Again, another tool I built. It's called Echo. It sits at the bottom here, and yeah, that's 100% running local. There's no API, so it's running on my hardware. Works on Windows and Mac. It's on my website, but I'm not in the shameless plug mood right now.
And
Um,
one question while this is going, PlayQuest asks, can the model listen to the audio and then create images based off of the audio at all?
yeah, great question. So you are required to have um, some sort of visual input alongside the audio. So you can't just use audio reference. But what you could do is say, here's a voice of a character and an environment, design the character based on the voice, right? Like you could do something like that, but it's the model will not just accept audio reference. It has to be paired with some sort of picture visual. It doesn't have to necessarily be a picture, it could just be white, right? Like doesn't have to be anything. But it will fail. Like it's fundamentally trained that way. Um, there's so much stuff you could do here. Like I know that I'm only scratching the surface. I'm kind of just diving into like a very niche application of this, but it's just so powerful. Like here I got a couple other examples. Here's a audio reactive video where the eyes on her shirt are blinking. And this one's prompted. That one was just straight prompted, so I didn't actually I wasn't using any of my system here. And then the last one I want to show is this one. This one's really cool. So same idea, but I prompted for more of like a narrative. So it's like this woman who can like make these like origami things, and it's just like all this crazy stuff happens. But it's just so insane, like how much. And that was just all off of a single picture. Um, but yeah, okay, so like it's prompted out these 11 clips. I can go in here and I can just take a look. It's like, sunlit park, blah, 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 all this stuff. So it did the thing, right? I can close down my agents and let's turn this to probably like 1024 just for the sake of time here. Turn these off and then I'll run it. And so, yeah, basically it's going to take this character. It's going to load my audio, which is this beat. And then it's now taking my prompt schedule, and this thing is taking it and cutting, this custom node is cutting it into condition markers. And I had to do some crazy math and like actually design some algorithms, because it's like, okay, I'm running at 24 frames per second, right? But I can subdivide time infinitely smaller than 24 frames. I can't have half a frame, but I could have half a second, right? And like, so it's like, okay, well, how do I account for this? And so in order to get my beat markers super accurate and have the frames be truly hitting where they need to hit, I made an algorithm that like adds a frame and takes a frame away and adds a frame and takes away. And it's constantly recalculating like, oh, we're too fast. Now we're too slow. Now we're too fast. Now we're too slow. And then that over the course of 3 minutes keeps the beat in time forever. And then I also had to pair it with the fact that most of these video models, they work in these like weird cadences. So for example, like if I just do like Hunyan, empty latent. Yes. Okay, perfect. So down here, if I go left or right, you would assume it would just be like, oh, 26, 27 frames. No, that's not true. It goes up by these increments. It's like, well, why? Why does that happen? Well, it's like the model fundamentally, I think it's because of like the compression. I'm actually not 100% sure, but like the model will fail if I try to render in a length bucket that like doesn't work with that model. And so I again had to account for that on top of my timing thing, so that I could, it's like, oh, you want to render 37 frames, and sorry, you can only render 39. It's like, okay, well, fine, render 39, then cut the two off. And then it was just an absolute mess of math I had to figure out mentally. But the results are super cool.
And I think this is like a great example of why the open weights are just so much more powerful than hitting an
Yeah,
API, because you could never get this level of control with just like a pure API call, right?
right. Well, yeah, I mean, I'm pretty sure I'm one of maybe 20 world first people. Probably there's probably like less than 100 people around the world that are doing exactly what I'm doing in the way that I'm doing it. And that's just insane, to be like, I'm a normal dude just chilling in my home doing cutting edge research like at the fringe of this technology. Like, and anyone in this room could be that, right? Like that's kind of what I'm getting at here. Um,
Especially with the little language models as an assistant, like you don't understand what any of these
mhm.
parameters mean. You don't understand the case sampler. Just ask, ask it questions until you figure it out.
Yeah, so here in the render, it's actually really good visual. Um, right now, if I open up my sequencer, the way I designed it was these four prompts are going to be one, then it's going to be a single render, single render, single render, single, and then three more prompts. So right now it's doing the singles, and you can see it's like ripping through. It's literally rendering sequentially in the 1K sampler to get all the shots done. So that was a fast one. So that was a single. And then this one probably, but what I've found is like doing it this way, doing it in singles, getting to choose where you want a big render and where you want a small render really speeds up the process. Like it's only been maybe 3 minutes so far, and I've already like, this one took 19 seconds, 25. This one was 2 minutes, so that was the first one. This one is the last one because it's about a minute of time.
And those are the individual clips that are coming out.
And you can see them when it starts to decode them. I actually have a loading bar here, so it's like decoding the chunks. And then it just compiles it all together. Now it's going to be low res. It's going to look like crap because it's 512, but I can see the motion of what like is going to happen. So it's like he got some ice cream, then a cut, and then he's walking. And so a lot of them are just like the same clip kind of vibe because the prompts or whatever. So you can kind of see the idea of where I'm like going with this, right? The pigeons and whatnot. It really does allow me to like schedule out a whole story.
Yeah,
And
and
it's just been
then
like, yeah,
this
go
is
ahead.
kind of like a low res preview, and then
Hmm.
once you feel good about the prompts,
Yeah,
the pipeline, you'll crank it up.
exactly. Yeah. So and that's exactly what's happening here. So I'm going to cancel that. But usually I was experimenting with different increments of like upscaling. So this is like 512 on the height, right? So this is a 512 resolution right here. But then this one I bring it up to 1024, and then the final one I bring it up to 1920. And I was experimenting this morning about just skipping straight from 512 to 1920, and it works. That's what this one was. This was skipped straight from 512 to 1920, and it looks pretty good. And there was one other render that I was testing that was high res. Where is it?
And Phil, what's your rig while you're looking for it? How much, what
Yeah,
GPUs you got?
yeah, yeah. My rig is let's see, where's the thing? Yeah, so I'm running a 6000 RTX 6000 Pro. So I've got 96 gigs of VRAM, and then I've got 128 gigs of, no, actually I have 96 in this machine, right? Yeah. So I have 96 of RAM, 48, and then I have 96 VRAM. So um yeah. And then I'm using just like an AMD 12 core um CPU. But yeah, that's one of the rigs. I have many rigs because I do this professionally, but yeah, the fact that you can run this thing on like a 3060 with like 12 gigs or 8 gigs of RAM, or a MacBook,
Yeah.
like that, the open source has really pulled it together for sure.
And
This
oh, here we go.
Yeah, this was a really interesting one. Just some like audio reactive melty stuff. I just like prompt scheduled, like turn this into different things, and it's just so cool. It's just so cool because I mean that probably took like 3 minutes to render. Like
Super cool.
anyway, that's
I
a
mean,
little bit of the stuff I've been diving into. All of
love
this is
it.
custom, so like this thing took me a lot of time, but now that it's working, I want to probably get it to the point of being able to schedule references, right? Because right now it's one set of references, one set of videos, but there is a world where each one of these could have its own reference image, reference audio, whatever, right?
Yeah. Awesome. Well, I know we're running close to time here, and we didn't even get to fine tuning. I did get fine tuning working last night, around like 1 a.m. So I think we'll dive into that next week or in a subsequent video. But it's live on Oxen if you want to try it out. I'll just give like a quick walkthrough of where you can find it. Oxen.ai models. I think fine tuning is just like a whole nother layer that you can come at this model with. Like if it's not good at fight scenes, we collect a big data set of fight scenes and try to fix those like tears or blurry things that come out of the video. That's one of the ones I'm playing with here. And how it kind of works on Oxen is you can collect a data set that's just kind of like pairs of videos and captions. And so here I just had my trusty data scientist Claude go to YouTube, grab, I think this is from 300, and caption all the shots. So like it's talking about these Spartan warriors, it's broken down each shot, it's even got our fancy tokens here, and in English he's saying push. So I've captioned this data set of about 100 videos. What else is in here? Born Ultimatum, Captain America. So I'm just trying to get like a bunch of different fight scenes captioned. You just come right here, click fine tune a model, or straight from the models page, you can filter down by fine tunable. We got MiniMax H3 right here. Um, and we're going to be training it to generate video. Pick MiniMax. We've got LTX, we've got one, pretty much all the open source ones you would want. It's kind of just walks you through like, okay, choose your model. If you haven't labeled your data yet, you can label it for you with an LLM, go through to the next step. And the configuration for this thing was the thing that took me the most amount of time to figure out. This is what I'll dive into in a subsequent video. But getting these parameters all set up correctly, like what's your learning rate, what's your LoRa rank, are we using a training adapter? There's like so much to dive into here. I think it requires a full deep dive. So anyways,
totally.
if you want to play around, like check it out, tweak the parameters. It works on Oxen right now, but that's way too much to dig into in 4 minutes here. So come back for next week.
Yeah, you'll probably want to use like the official prompting guide for the captioning as well. Don't try
Yeah,
to
totally.
fight the grain.
Give it a good starting point for everything. If you had a large enough data set, maybe you could overcome that and like
Yeah.
get it working on shorter prompts, but like 100 videos, probably not going to do it with just that.
Yeah, the fun part here is like, you have audio too. So I was thinking of making a LoRa on Guitar Hero and
Oh,
essentially teaching the model that like I could give it any song and it would just spit out a visual that looked like it was being played on Guitar Hero. Just something dumb, right? Like what could I do with audio that would be interesting, right? Like obviously dialogue is like the most, obvious answer, but there's so much more, right? Um, Even like rhythm games. I was like, what if I just train it on like a rhythm game, you know?
yeah. Yeah, totally. It's like, you know, there's the prompting control layer, there's the reference control layer, and then there's getting down to the model weights themselves. And that's where you
Mhm.
just can kind of unlock anything. So, with enough data prep and enough time, and yeah, it's really exciting.
And enough compute.
Enough compute. Yeah, yeah. But if you think about it, like what one Seedance render can be $10, $15, depending on you're doing like a 30-second Seedance 2.0 render, you can train the whole model for that and then start running it locally. So
Mhm.
the return on investment is pretty high.
Yeah, totally.
Cool. Well, we're coming up on time here. Thanks, Phil, for showing. Like those ComfyUI things always blow my mind. If you guys want to reach out, if you have custom work that you need done, if you have workflows where you're like, is this even possible? Just hit me up, hit Phil up. We're happy to answer questions and like get our hands dirty with you because this is fun. Like this is what we love to do. So
Totally. Yeah, thanks so much
cool.
for having me, guys. Yeah, hope to come on again and deep dive some training stuff when we actually get around to it.
Yeah, totally. Let's get that on the schedule. All right, I'm gonna kill the recording. We can hang out for a few minutes if you guys want, but
Thanks,
thanks
guys.
for watching.